Okay, today we're going to be learning about the 1.4 units of measurement, and this is not really chemical theory. This is just going to be simple lab stuff that will be useful to you, hopefully, if you're not being self-taught. But this is just useful in the lab. So we'll go over quantitative properties, which are properties described using numbers. We touched on this last video. These can be things such as measuring mass, which will be in grams. So whatever uses units. And units are things like centimeters, grams, or milliliters, where you can measure them objectively. Um, right? I guess temperature is also a unit, depending on which unit you use, like Celsius, Fahrenheit, and we'll touch more on that later on this video. A metric system is just a measurement system based on units, like meters, grams, and liters, which are used in science. The standard units that we use in science are actually from the SI units, from the French System International. You don't have to know that. Just know that we use these units that will be displayed in the next slide here. So first, for length, we use meter. For minutes, we use kilograms. Time, we use seconds. Temperature, we use Kelvin. Now, the important thing to know here is we don't need to worry about these bottom two, electric current and luminous intensity. These are just if you want the entire um, base units. However, the ones you really need to worry about is honestly just the temperature. Temperature is always measured in kelvins, and we'll get to that later because it was introduced actually because of chemistry. And you'll never ever use Celsius typically. You'll always use Kelvin. Um, and yeah, that's just the SI base units. The prefixes in SI units will definitely be helpful. There's more than this, but these are the basic ones you'll use. There's things like tera, giga, mega, kilo, centi, milli. So for example, the base one is going to be 1, right? And a centi is going to be 0.01 of that 1, or just 0.01, obviously. My teacher taught me that it's like a cent. A cent is 0.01 of a dollar. So yeah, that's what it is. A temperature is for temperature, we have Celsius, Kelvin, and Fahrenheit. Always use Kelvin in this class. All the formulas are going to use Kelvin no matter what. You don't have to worry about Kelvin right now, but Celsius and Fahrenheit formulas are right here. And Fahrenheit is typically used in the United States. Kelvin is going to be used in all chemical formulas. We're only going to use Kelvin. Make sure to understand that. And Celsius. Sometimes they'll give you stuff in Celsius, but all Celsius or all Kelvin is Celsius plus 273. So that's all it is. As you can see here, we're given the Fahrenheit formula, which is 9/5. The and C is just going to represent Celsius plus 32 degrees. And you can find Celsius when we're rearranging this because Celsius is going to be equal to F minus 32 times 5/9. So this is the Celsius formula if you were curious. I don't know why I don't have it on here. But the next slides will be pretty interesting. We're going to be learning about volume measures. And my teacher was just such he was huge on this because the graduated cylinder is what we use most of the time to measure volumes, and that's pretty accurate, right? Although the pipette is definitely definitely accurate, and a volumetric flask is also really accurate. However, there's a thing you need to watch out for, and that's going to be beakers. They have volume measurements on there, but they're not accurate. And our teacher would always get mad at us for doing that. But yeah, just know these are the volume measures. You're not really gonna have to know this for now once we actually get into the lab. To be honest, I'm not even sure why I'm teaching this. I'm supposed to be teaching chemical theory, but that's what it is. Um, Density. It's basically how much mass is in a given volume. So if we have, I believe water at standard temperature is 1 gram/milliliter. So that means every milliliter of water weighs 1 gram. You can calculate this formula using mass divided by volume. So you might ask me, what units do we use? Well, the most common one is grams over milliliters. That's typical. Will always be given. By the way, a milliliter is equal to a centimeter cubed. They're the same thing. Um, but yeah, always just divide the mass divided by volume to get the density of a substance. You just yeah, that's pretty much it. Water's density is 1 grams per milliliter temperature. Room temperature, not in standard temperature, but yeah. High density means that in a certain amount of volume, there's a lot more mass, and low density equals less mass and more space. Now, as I said, you want to absorb the information, so make sure you understand what density is first, and you won't even need to know this because you'll already be able to figure that out, just like that. So, yeah, that's 1.4.